The data from exercise 1 are as follows. And here's a scatter plot of the data together with a simple linear regression line. Compute the mean square error. So the mean square error using the formula in the textbook comes to 4.133. Compute the standard error of the estimate. So S is the square root of the mean squared error, so that comes to 2.033. Compute the estimated standard deviation of B1. So using the formula in the textbook, that comes to 0.643. Use the t-test to test the following hypotheses at a significance level alpha of 0.05. Null hypothesis beta 1 equals 0, alternative hypothesis beta 1 not equal to 0. So the t-statistic comes to 4.044, and then we need to find the p-value corresponding to that test statistic. So if we look up some percentiles in the t-table, there'll be 3 degrees of freedom that we need to use, and looking at the table, we have 3.182 corresponds to an upper tail of 0.025, and 4.541 corresponds to an upper tail of 0.01. Our t-statistic is in between those two percentiles, so therefore it has a upper tail that's in between 0.01 and 0.025, and since we're doing a two-tailed test, we need to multiply that by 2 to find out bounds for the p-value. So the p-value must lie in between 0.02 and 0.05. And that allows us to make a decision because we can see that the p-value is less than 0.05. If we use statistical software like Minitab to find the p-value for us exactly, we can obtain the value 0.027 for the p-value. So that confirms that it's less than 0.05, so we reject the null in favor of the alternative, so there is evidence that the population slope is non-zero. Use the f-test to test the hypotheses in the previous t-test at a 0.05 level of significance. So the f-statistic, so using the formula in the textbook, we obtained 16.35 for the f-statistic, and note that if we take the square of the t-statistic that we just calculated, we also get 16.35. And so we can see the relationship between the t-test and the f-test for simple linear regression. To find the p-value associated with 16.35, we can look up the F table with 1 numerator degree of freedom and 3 denominator degrees of freedom, and 10.13 has a tail area of 0.05 and 17.44 has a tail area of 0.025, and f-tests are always upper tail, so the p-value, the tail area corresponding to the f-statistic 16.35 must be in between 0.025 and 0.05. And we already discovered that Minitab gives us that p-value exactly. It's 0.027, and that confirms that it's between 0.025 and 0.05. It's less than 0.05, and so again we get the same conclusion that we got with the t-test.